All right, here we go. Bring it back to triangles. Remember, vertices of triangles always get labeled with capital letters. The sides, their corresponding sides, should ideally get labeled with lowercase. Lowercase letter is always the same as the corresponding vertex across from it. What does that mean? Well, that means something like if this is side A, then this corner across the triangle is vertex A, or corner A. If this is side B, then across the triangle is vertex B. And then that would make the remaining side side C, and the vertex, the corner across from it, to be corner or vertex C. We're looking at triangles. A right angle triangle. Right angle means it has 90 degrees. If we want to find angles, we have 2 out of 3. You can use the sum of the angles for triangle theory. Oh yeah, all that. We're not done with it. Right, remember that angle B plus angle A plus angle C all equals 180 degrees. We're dealing with side lengths. We have 2 out of 3. Pythagorean theorem. Remember that one? Oh yeah. So if it's 90 degrees, a squared plus b squared equals c squared. We have a combination of sides and angles. 2 sides and an angle, and we have 2 out of 3. We're going to use our trigonometric ratios. So, TOA. Oh, we aren't done with those. Bring them back. So, I'm going to make you dig deep. Solve for the missing angle or side, whatever it is. We have y. Okay. Side, side, angle. We use SOHCAHTOA. So we're looking at this corner. So let's start thinking about what do we got. We have an opposite. We have an adjacent. And we have a hypotenuse. Remember how to line those up? Oh man. So what do we have? We have a hypotenuse and we want to find our adjacent, A and H. So, cat. Remember the C stands for cosine. The cosine of the angle, 20 degrees, is equal to adjacent over hypotenuse. We would treat this, remember the cosine 20 is just a number. It might be a decimal. So we're not going to change it yet. We're not going to put it into a decimal because it goes on forever. We want to keep it that way until the final answer. So y divided by 13, to isolate for y, we're going to multiply the right by 13. Whatever you do to the right, do it to the left. Math is fair. So in our calculator, our solution is going to be 13 times cosine of 20. Do that in your calculator. Remember how to do that? Do it. What does y equal? Write that down. Oh yeah. Round to 2 digits. Write that down. Do it. Do it. Don't just stand here. I'm not going to write it in. Okay, let's look at the next one. There's the corner that we care about. From that corner to the 90 is our adjacent side. On the opposite side of the triangle, that's our opposite side, and from the 90-degree corner, there's our hypotenuse. What do we got? We have hypotenuse, we have an opposite, we're trying to find the angle. O and H. O and H. Sine. Sine of our angle, we don't have it, is going to equal the opposite over the hypotenuse. To get our angle by itself, we're going to take sine -1 of that entire side, which means we're going to take sine -1 of the right. Math is fair, always. Those cancel out. So the angle is going to be sine -1 of 7 divided by 12. 7 divided by 12 is a repeating decimal. We're not going to change that. Just enter this all in your calculator. Remember how to do it. Do it. Do it. Those are your skills. Don't just copy down blindly. Okay. Once you get your two answers, jog your memory. What happens though if we get to a triangle that doesn't have a right angle? How are we going to solve that? Well, really, there's a simple way, but if we think about it, and you ever had to do this, why wouldn't we drop a hypotenuse down to the big one at 90 degrees, and now we've made two right angle triangles. We have one there, and we have one there. And so if we looked at this corner, call this triangle 1, and we needed to find the angles, we could look and say, all right, compared to that corner, there's our hypotenuse, here's our adjacent, and there's our opposite. And so could we find that height? And so for that first triangle, in bright pink here, we have got sine of 78 degrees. It's going to be opposite over hypotenuse. It's going to be that opposite over hypotenuse 1.8. And this is going to be tough because it's in bright yellow now. And if I look at that corner, the same thing still applies. From that corner to the 90, that's still adjacent to this triangle. This is still the opposite for that triangle, and this is still the hypotenuse. And the opposite for these two triangles is going to be the same, so that's why I've used opposite and what I have. So if I think about this second triangle, same thing applies. Sine of 53 degrees is going to be the opposite over 2.2. Now if I rearrange to isolate for the opposite, times 1.8 times 1.8, and over here times 2.2 times 2.2, those numbers should be the same. Those should be equal because that opposite is the same for both triangles. When I do the math and I enter my calculator, 1.8 sine 78 degrees is 1.76. 2.2 times sine 53 degrees is 1.76. So that opposite is 1.76. So really, if I think about it, then that is equal to that. So let's just take that for a second. Now, I'm just going to do something really, really random here, but I'm going to say on this side, I want to get that 1.8 by itself, so I'm going to divide by sine 78 degrees here. Whatever I do to the left, I got to do to the right. So I got to divide by sine 78 degrees here. That sine 78 is gone. At the same time, if I want to get rid of the sine 53 on this side, I divide it by sine 53. I need to divide the left by sine 53. Sine 53 divided by sine 53 is 1. So we have something left over here. So what did I do? Why did I do that? What I've done is I have 1.8 divided by sine 53 degrees is equal to 2.2 divided by sine 78 degrees. Prove that they're even, just rearranged. So when I look at that, how does that help me at all? If I look at that big triangle again, and I look at where is 1.8 and sine 53. 1.8 is there, and sine 53 is there. They are across the triangle from one another. If I look at 2.2 and sine 78, they are across the triangle from one another. What I have done is I have just proved or figured out the sine law. So let's flip the page and let's look at the next example here. Again, if I look at vertex A with side A, vertex B with side B, and vertex C with side C, and I do the math, if I have A, so the length of side A divided by sine 87 degrees, I typed on my calculator, I got 7.91. If I take the length of side B divided by sine of vertex B, 44 degrees, and I typed out my calculator, 7.91. This is getting exciting. If I take the length of side C divided by sine of that corner, 49 degrees, and sine, because I just saw that sine's going to be the same, so I'm using sine, and I do that, and what do you know? I got 7.91. So what did you notice? They're all the same. Look at that, we just proved it. So, what did we just do? We just found out that sine law. What is actual sine law? We take the length of side A over sine of angle A, that will be equal to the length of side B over sine of angle B. And all of that will also be equal to the length of side C over sine of angle C. And really, because we're going to use 2 out of 3 sides, depending on what we have to find, side or angle, I can decide how I write it. So I could write it the other way around. Sine of angle A over the length of side A, it's going to be equal to sine of angle B, vertex B, over the length of side B. And all of that is going to be equal to sine of vertex C over the length of side C. So just to remind ourselves, or just to think, we are only going to use 2 of the 3 ratios at a time. So when do we use these? When do we use sine law? If we have a non-right angle triangle, and we have or can find a side and its matching angle across. I'll write that in part 2.